I know most of you have not done probability since like 7th grade. It's fine. I just want to kind of go over just the very basics of probability. There's not a lot of questions on the Regents about it, but if there is a question, I want you to get it right. Just a couple of simple formulas. So let me just kind of go over just like the basics of what probability is. So probability is always just the part, it's a fraction. A part over the whole is all probability is, right? What is it, the part that you're looking for over the whole? So for example, in this question that we have right here, we have a jar containing 32 red and 28 blue. What is the probability that a randomly selected marble is red? Okay, so we're looking for red. So how many reds are there, right? So there are 32 red marbles out of what is the total? So to get the total, you take these and you add them together. So 32 plus 28 is 60. So 32 out of 60 is our fraction. And then you want to try to simplify whenever possible. We already know how to do that, right? Alpha y equals option number 1, put the 32 on top, the 60 on the bottom, and the calculator does the simplifying for you. So it's 8 out of 15. So the answer to this question is 8 out of 15, okay? The probability that it will snow tomorrow is 7 out of 20. So the chance of snow is 7 out of 20. So therefore, the chance that it will not snow, right, which is what we're looking for, is going to be the remaining, right? So 20 minus 7 is 13, and we always have to put it over the total. So 13 out of 20 is the probability that it will not snow, okay? And you can't reduce that. What's the probability of drawing a diamond from a stack of cards, a standard deck of cards? I said stack. For those of you that don't know what a standard deck has in it, okay, so these are the different sets of cards. So there are 4 kings, 4 queens, 4 jacks, right? 4 tens, 9, 8, 7, 6, 5, 4, 3, 2, and instead of 1, they have aces. So we're looking for diamonds. So here are all the diamonds. Okay, so diamonds, hearts, spades, clubs. So these are all the diamonds. So if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 diamonds out of a stack of 52 cards. Okay. So our answer to this question is 13 out of 52. Good. And if you reduce this, right, take your calculator, do your alpha y equals, oh, wrong one, alpha y equals, and then we put 13 on top out of 52 on the bottom, and you're going to get 1/4, which makes complete sense because if you look at it, there's 1 diamond for every other four sets of cards, right? So 1 diamond out of 4, 1 out of 4. So 13 out of 52 reduces to 1/4. Good. So I definitely want to go over the basics of probability, some formulas that you do need to memorize. So the word, whenever you see the word and, it means to multiply. So the probability of and, the symbol for and is like an upside down U. The probability of A and B is equal to the probability of A times the probability of B. So this is an example, okay? A dice is rolled and then a coin is tossed. What is the probability of getting a 5? And then tails. So this is what we're looking for. So first thing is I saw the word 5, then tails, right? So this is a times, this is we're adding, we're multiplying them because it's one and the other. And so it says a dice is rolled, so we're looking to get 5. So think about a dice, right? In a dice, there are 6 sides and there is 1 5. Okay, there's 1 5 in a dice out of 6 total things that are on it. And for tails in a coin, right? How many tails are there in a coin? There's 1 tail out of 2 faces. So since we want both 5 and tails, we're going to multiply that, and this gives us 1 out of 12. Okay. The word or means that we're going to, right? So and means to multiply, or means to add, and then we're going to subtract anything that's in both. So for example, the probability of drawing a 9 or a diamond. So we already know a diamond, right? We did that in the do now. So there are 13 diamonds out of 52. So first thing we're going to do is, this is the probability of the sex. So diamond is right here, so that's 13 out of 52. Let's go back to our deck and see how many nines are there in the deck. So let's go back right here. So there are 1, 2, 3, 4 nines, right? So there's 13 diamonds and there are 4 nines. So getting back to this, so there's going to be 4 out of 52, and it says in the formula we're going to plus them together, and then we're going to subtract how many are both a 9 and a diamond. So if we go over here back to the stack, right? So there's only one, right? That's a diamond and a 9. So this is being double counted, right? When we look this way and we look this way, this 9 right here is being double counted, so we have to subtract that 1. So minus 1 out of 52. And so we're going to figure out what that is. So let's use our calculator. So this is 4 plus 13 minus 1, and that's going to give us 16. So this is going to be 16 out of 52. And then we're going to take that right there. So alpha y equals option number 1. We're going to do 16 on top, 52 on the bottom, and we're going to reduce this into 4 over 13. So our final answer to this question is 4 out of 13, right? Equals 4 over 13. And all we did is we just applied this formula, okay? So this formula, please write this down. This will not be given on the Regents to you. You have to memorize it. All right, the next rule is something called given. Okay, so like, for example, given the chance that it's raining, right, or the probability that it's raining, what is the probability that you have an umbrella? Okay, so that's like what the word given means, and this is the formula for it. The symbol for given is like a little line right here. So this is and, this is or, so and, or, and a line in between it means given. Okay, so you do need to know that. So Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen? So the probability that he drew a queen given that the card was red. So given that it was red. So let's go ahead and instead of A and B, let's use the variables that we wrote right here. So the probability of both of them happening, right, that it's a queen and red, over the probability of the second. So you can kind of think of this as like a division symbol. So the probability of red goes on the bottom. So probability of red. Okay, so let's look at this. So queen. How many queens are there in our deck? Right? So there are 4 queens in our deck of cards. So 4 of them are queens and red, right? So it has to be 4 red queens. So if I go over here, there's only 2 red queens. So I'm going to change that to a 2. So queens and red divided by how many red cards are there. So let's look back at the deck. So this is 13 cards and 13 cards, right? So total red cards is going to be 26. So 2 out of 26, and that simplifies to 1 out of 13. Okay. And the last thing that we have are two formulas to test for independence. So to figure out if things are independent or two things are independent or not. Like for example, right? The probability that I will see a squirrel, and the probability of me turning on the light when I come home today. Okay. They have nothing to do with each other. They are not dependent on each other. But if I have marbles in a hat and there's 10 marbles and I take one out, uh, so one blue out of 10, then now there's one less marble in the bin or the bag, so that's going to be dependent on each other. Okay, but we'll do a couple of examples about that to help you. So model problem number 1, a bag contains 2 red marbles, 7 blue, and 5 green. 2 marbles are drawn out of the bag. What is the exact probability that both marbles drawn will be blue? So how many total blue marbles are there, right? There are 7 blue marbles. So if one of them is taken out, how many blue marbles are left, right? So if one of these are taken out, there will be 6 of them left. So what is it that we're looking for, right? We could draw a picture if necessary. If both happen, is that and or is that or? So if both of them happen, that is going to be and, so we're going to multiply them. So there are 7 total marbles out of, how many marbles are there altogether? 14. And then if we take one blue out, right? We take one of these blue ones out, there's going to be 6 left out of, and now the total marbles is now not going to be 14 anymore, right? Because we took one of them out, and it's going to be 13. So then let's go ahead and use our calculator to figure out what this is simplified. So I have my alpha y equals right here. I'm going to put 7 over 14. And then I'm going to go here, multiply by another fraction. And again, you should be doing this with me. So 6 out of 13. Hit enter in my calculator and I get 3 out of 13. So final answer for this question is 3 out of 13. Is the probability, the exact probability that both will be blue. Okay. All right, model problem 2. So first thing that you want to do whenever they give you a question that looks like this is you want to make sure that you find out the totals, right? So you want to kind of like go like this, add some extra spaces. So this 10 plus 3 is 13, 5 plus 9 is 14, 9 plus 3 is 12, 10 plus 5 is 15, and then if we add this together, that's going to give us 27 total, right? So what is the probability that a student has a brother given that they have a sister? So probability that a student has a brother given that they have a sister is the question. So remember for our given formula, right, we have to find out how many, what are the two things and how many of them have both, right? How many has a brother and a sister? So has a sister, has a brother, 10, right? So 10 of them have a brother and a sister. And then we have to look at whatever is second, right? So after the word given is sister. So we're going to find the total number of sisters that there are. So has a sister, total number is 15. So 10 out of 15. And if I reduce that in my calculator, 5 goes into both. So that's going to be 2 out of 3. So that's my answer, right? So what I'm going to ask you to do right now is to go ahead and do this check for understanding, and then you're going to do some Delta math problems, and you can come back to this worksheet to work through these problems. These are Regents questions and what they look like. All right. Thank you. Good job.